So, welcome again. This is Physics 1.0 and the second chapter. The first chapter was actually an introduction where we discussed what physics really is. But in this chapter, we'll be talking about measurements. Now, what do we want to discuss first? We want to talk about order of magnitude. When we say order of magnitude in physics, what are we talking about? In fact, most estimations in physics are usually given in standard form or scientific notation and order of magnitude. Not only in physics alone, even when we are talking of statistics, populations, and likes, it is usually interesting to give or to quote in scientific notation or order of magnitude. An order of magnitude is just more or less like a mental calculation. Let's say you want to quickly get a rough estimate of a particular of something. So it is best uh, gotten using order of magnitude. Quickly, you get whatever you are talking about. Now, when we say order of magnitude, what do we mean? It is the scale or size of a value and usually expressed as the power of 10. Yeah, order of magnitude is usually expressed as a power of 10. Now, we are going to look at how to get order of value. How do we order of magnitude? How do we calculate order of magnitude? Now, how to find order of magnitude? Now, the major thing is that you take the base 10 logarithm of the number and round it to the nearest integer. So if you want to find the order of magnitude of any value, you just take it to base 10 and then you find the nearest integer. For example, for 800, how do we find the order of magnitude of 800? So just put that 800 in base 10. If you find that 800 in base 10, you get roughly 2.903 using your calculator. And 2.903, when you approximate, that is approximately 3. So it means the order of magnitude of 800 is 3. Now, 400. How do we find the order of magnitude of 400? So take that 400 to base 10. The logarithm of that 400, find it in base 10. And roughly what do you get? You get 2.653, which is approximately 3. So it means the order of magnitude of 400 is 3. Now 250, what's the order of magnitude of 250? You find the logarithm to base 10 of 250, whatever, and you have 2.397, which is approximately 2. So it means the order of magnitude of 250 is 2. Now, that's not the only way of finding order of magnitude. There is also another way of finding order of magnitude. Now, what's the other way of finding order of magnitude? Another method of finding order of magnitude is write it in scientific notation. Yeah, write it in standard form. And for example, 800. If you write 800 in standard form, that is 8 times 10 raised to the power 2 in standard form. So that's 8 times 10 raised to the power 2. So you find 800, 8 times 10 raised to the power 2. Now, you look at the first value. The first value there is 8. Now, is 8 greater than root 10? You check if the first value is greater than root 10 or less than root 10. That's what's important here. Now, if you look at, and root 10 is approximately 3. If you find root 10, it is approximately 3. So what we are saying is that is 8 greater than 3? If 8 is greater than 3, you round it up to 1. So we discover that 8 is greater than 3, so which is round up to 1. So it means the order of magnitude now will actually be, instead of this 10 raised to the power 2 before, it will be uh 10 raised to the power 2 plus 1. So that will be 10 raised to the power 3. So the order of magnitude is 3. Now 400, if you write it in scientific notation, that is 4 times 10 raised to the power 2. Now the first value there, which is 400, is what? The first value there, which is 4, is greater than root 10, because root 10 is approximately 3. So 4 is greater than 3. So if 4 is greater than 3, so you come um, to the other value there, which is 10 raised power 2. So that 4 has been rounded up to 1. So that's 10 raised power 2 plus 1, which is 10 raised power 3, which is also 3. So that's another way of finding order of magnitude. Now, the order of magnitude of a number is designed to be a ballpark estimate for the scale of its value. It is usually good to find things using the order of magnitude when you are talking of physics. It is interesting. For example, you want to find something about the diameter of the sun, the diameter of hydrogen atoms, stuff like that is best quoted using order of magnitude. So it gives a good rough mental math with very big and small values. Now, for example, we know that the diameter of hydrogen atom is 1.06 times 10 raised to the power minus 10. And the diameter of the sun is 1.39 times 10 raised to the power 9. Now, how much hydrogen atom will stretch across the sun's diameter? Of course, if you don't know the diameter of the sun, but you know the order of magnitude of the sun, you know it's, and also you know that of hydrogen atom. So it is very, very easy for you to find it. Now, if we actually do this one, if you find the exact calculation, so that would be the diameter of the sun over the diameter of hydrogen atom, which is 1.39 times 10 raised per 9 over 10.06 times 10 raised per minus 10, which is 1.31 times 10 raised per 19 hydrogen atoms. It means it takes what? 1.31 times 10 raised per 19 hydrogen atom to stretch across the whole diameter of the sun, right? Which is actually, it means the order of magnitude is what? Is 19. So the order of magnitude of hydrogen atom that will stretch across the whole diameter of the sun is actually 19. But if we do it using order of magnitude, just the 10 raised per 19 there, sun divided by hydrogen, that's 10 raised per 19 over 10 raised per minus 10, which is also 10 raised per 19. You see, in the long run, we have 10 raised per 19 here. We also have 10 raised per 19 here. So we know the order of magnitude by that. So order of magnitude is usually is just a fast way of finding uh, a particular length, a particular scale. So a rough and a quick way of finding it, apart from using uh, the normal size or everything that's has been given already. So let's say, for example, you don't know the normal size, but you know the order, you know the order of magnitude. It is usually easy to get a feel for that particular phenomena using order of magnitude.